Now, our next piece is taking these basic exponential functions, and we want to incorporate the idea of the inverse function to that. Now, recall that when you have a function, in order for that function to have an inverse, the function must pass the horizontal line test. Any horizontal line can intersect the graph of the function in at most one spot. Well, so if b is greater than 1, then we know this is the graph of the function. And that graph passes the horizontal line test. This function has an inverse. If b is between 0 and 1, that's the graph, but that also passes the horizontal line test. So, as long as we assume b is greater than 0 and not equal to 1, so long as b is a valid choice for the base, these functions will have inverses. All right? Now, another piece of the puzzle is that if this is the graph of f, then we know that the graph of the inverse, this is badly drawn, but it is the mirror image, the reflection of itself across this line y equals x. So if this is f, this is f inverse. If this is f, this is f inverse. So these functions are inverses of each other. They are the reflection of each other across this diagonal line y equals x. All right? Well, these functions pass the horizontal line test, therefore they do have an inverse function. This one isn't too bad to draw. Notice this is asymptotic to the x-axis, negative. The inverse will be asymptotic to the y-axis, negative. What was x becomes y, what was y becomes x. And so, we know this passes through the y-axis at 0, 1. So that means 1, 0 must lie on this graph. And within the limits of my badly drawn picture, if this is f, this is the inverse. This is f of x equals, or we'll call this y is equal to b to the x. This is the inverse of that. All right? This is a little more challenging to draw because it actually crosses over this. So again, now the notion is this is asymptotic to the x-axis positive. The inverse will be asymptotic to the y-axis positive. This crosses at 0, 1, 1, 0. And so if I can draw this picture reasonably accurately, this would look something like that. It is the mirror image as you reflect across this line. For our purposes, this is much less common. This is much more common. This is the inverse of the original function. All right? This function is called logarithm. The inverse of an exponential function is a logarithm. If you've ever heard of the word logarithm, or maybe if you haven't, logarithm comes from a Greek word that means inverse of an exponential function. That's probably not true, but that's the way to think of it. It almost certainly is not true, but that's the way to think of it. A logarithm is simply the inverse of an exponential function. They are inverses of each other. Now, logarithm takes way too long to write, so we abbreviate logarithm log. Now, the problem is this. If we start with the base b, if this b, remember anything greater than 0, not 1, so if b is bigger than 1 over here, so we can have, the base could be 2, could be 5, could be 10, could be whatever. If it's 2, that might be the graph. If it's 5, that might be the graph. If it's 10, that might be the graph. So there are many different exponential functions, and that's indicated by using the number. So we have, this would be 2 to the x, this would be 3 to the x, maybe this is 10 to the x, whatever we had. Well, now when we draw this inverse function, we need somehow to delineate between which of these we're talking about, because which of these we talk about depends upon which of these we started with. And so, if we start with b as the base for the exponential function, then we write subscript b for the logarithm. And so we write this as log base b of x. This is the inverse. If f of x is b to the x, then f inverse is log base b of x. And vice versa. If this is f, then this is f inverse. They are inverses of each other. Anytime you see log, that's short for logarithm, and all that means is it's the inverse function. Now that has sort of several ramifications, and we'll talk about that as we go. But this is simply to introduce the notion. So you may have several different functions. You could have f of x is equal to log base. Any b that is viable, that is bigger than 0 and not 1, any b that's viable may be used. So you can have log base 3 of x, or you could have log base 7 of x. You can have any base you desire so long as the base is bigger than 0 and not 1. You could, in this scenario, choose a value between 0 and 1. You could have h of x could be log base, whatever, it could be log base 1/3 of x. No one ever does that, but if you wanted to, that'd be wonderful. So the base simply tells you which specific exponential function you started with. We'll look into how these relate to each other and the computations you need to do. But for now, that's just the familiarity with the symbols, the notation. When I write log base b, what that means is if f of x is log base 3 of x, then this means that f inverse is 3 to the x. If g of x is log base 7, this means that g inverse is 7 to the x. Logarithm function, exponential function, they are associated with each other. Log base 3 of x is inverse to 3 raised to the x power. Log base 7 of x is the inverse of 7 raised to the x power. And we'll investigate these more in more detail here.